Let's verify the identity that cosine 2 of theta is 1 minus tan squared over 1 plus tan squared. Let's see here now, how can we verify it? Now first, here, we want now to verify that this part equals cosine 2 theta. So 1 minus tan squared.
Teacher, I want to record
Yes, miss, I'm recording.
because it's not like
No. 1 minus tan squared of theta over 1 plus tan squared of theta. So here now we want to verify that this rational function here equals to cosine 2 of theta. Now, first of all, let's try to simplify tan. Let's say that tan is 1 minus, before that, let's remember, before simplifying it. Now we remember that we have 3 Pythagorean theorems for our 3 Pythagorean identities. Sine squared plus cosine squared equals 1, and 1 plus tan squared equals secant squared. So here what did we have? We have 1 plus tan squared. So let's now replace 1 plus tan squared with secant squared. Up, keep 1 minus tan squared of theta as it is. So 1 plus tan is secant. The second step. Now, all of us know that if we have x minus 1 over 4, we can distribute it as x over 4 minus 1 over 4. But if you have x minus 1 over x plus 3, you cannot say it's x over x minus 1 over 3. This is incorrect. You can say it is 1x over x plus 3 minus 1 over x plus 3. You will distribute each part on the numerator in the whole denominator. So here, as we did in algebra, we can do in the trigonometry. Like if we have 1 minus tan squared over secant, we can distribute it as 1 over secant squared minus tan squared over secant squared. Then let's try to rewrite secant as cosine, or sine, tan as sine, and so cosine. Let's now replace them to the to the 2 original ratios. So 1 over. Now we know that secant squared is 1 over cosine squared minus. We know that tan is sine squared over cosine squared. And we know that secant is 1 over cosine squared. Then, and all of us know that if we have 1 over 4 over 2 over 4, both of the denominators can be simplified. So we can write it as 1 over 2. And here is the same. I can cancel cosine with cosine in order to have sine squared over 1. And we know that if we have 1 over x, this is equal to 1 divided by 1 over x, or 1, change the division to multiply, reciprocal of x is x. So it's supposed to be x. So 1 over x is x. So 1 over cosine squared is cosine squared. Then cosine squared minus sine squared is equal to cosine 2 of theta. Is it clear?
Teacher, I did it in the wrong way because I somehow canceled the power 2, but I still got the same answer.
How you did it?
I don't know, I did it in a different way, but I forgot that there is the squared. So without the squared, I also got the same answer.
Oh, okay. I understood. Maybe you know it as 1 minus sign times 1 plus 10.
Yeah.
Oh. Yes, Habiba.
Teacher, where did the sign go? The sign squared.
This one here. Hey, it's here. Just a minute. Okay. Hey, it's here. Cosine cancel cosine, and this sign I wrote it down. So cosine squared minus sine squared is cosine 2 theta.
Okay.
Got that? Which we know that we have 3 identities for cosine 2 theta. One of them is cosine squared minus sine squared. Which is the cosine double angle identity.
So teacher, here in this lesson, we're going to concentrate about the Pythagorean identities, right?
Yeah, somehow, yeah, you will use what did we learn before in order to verify these identities.
Okay, teacher.
Okay. Now, do you have any question?
No, teacher, thank you.
No, it's clear.
Now this one here. Verify the identity that 2 cosine 2 theta is 4 cosine squared minus 2. 2 cosine 2 theta is 4 cosine squared of theta minus 2. How we verify it? We know that cosine 2 of theta, one of their identities, 2 cosine squared of theta minus 1. This is of cosine 2 of theta. But what did I want? I want to multiply. I want 2 cosine. So if I multiply this part with 2, I must multiply this part with 2. So what did we have? We have 2 cosine 2 theta is 2 times 2, 4 cosine squared of theta minus 2. That's it.
That was easy. Yeah.
Just like this?
Yes. Now let's give you another example like
Teacher, but I'm just asking myself, how are we going to verify identities in the final exam? Like, how are we going to write it?
let me think. Maybe I will give you what some examples, and I will ask you to send me the answer on WhatsApp.
Teacher, we can't have the quiz at the school or something?
No, this is from Ministry of Education that you're supposed to make that. Wallahi, I hope you. It must be at.
Even if it's only the math quiz, just the math quiz.
Teacher, please, wallah.
This is not my. Okay, I will try it. I will ask Ms. Kifaya. Inshallah, I will hope. No, I hope, sorry.
Teacher, like, if you give us like essays, can I just send it to you in the Whats, not like copying and like that?
Let me see if there's. Let's skip it the final. We have a lot of time. If when I prepare the exam, I will tell you how the questions will be, and if they're gonna stay, what's supposed to do.
Okay, teacher.
Okay. Now let's solve it here. No, I want to verify here. Where's verify? Here, you need to solve, not to verify. Number 49. In your book, here we have 4 sine 2 of theta minus 3 cosine of theta equals 0. Okay, use identities to write each equation in terms of the single angle, then solve the equation for theta greater than or equal 0 less than 2 pi. Here now, we want to solve it. What's the meaning of solve it? That means we know to find the values of theta. Now, first of all, sine 2 theta, let's rewrite it as 2 sine theta cosine of theta. Sine 2 theta is 2 sine theta cosine theta minus 3 cosine of theta. Then let's distribute it here. 8 sine of theta cosine of theta minus 3 cosine of theta equals 0. Then what do we have to do? Let's take cosine as a common factor. So we have 8 sine of theta minus 3 equals 0. So that's mean cosine of theta, it could be 0, and 8 sine of theta minus 3, it could be 0. Now when the values of theta of cosine is 0,
Is it 90?
90 and 270.
so pi over 2 and 3 pi over 2. And 8 sine of theta minus 3 and at 0. And cosine is 0, 3 at 270 pi over 2. Oh yeah. Now cosine 8 sine of theta minus 3 is 0. By calculator, sine inverse of theta of 3 over 8 will be which angles? Just a minute, I will see. So here,
22.
yeah. So here, I will rewrite it. Cosine of theta, it could be 0, and 8 sine of theta minus 3 could be 0. So as we said, cosine of theta is 0, so when theta is pi over 2 and 3 pi over 2. And here, I want to solve it. So sine theta is 3 over 8. So theta will be sine inverse of 3 over 8. So from the calculator, you will find that at, just a second, please. Sine inverse of 3 over 8 will be 22 point, or approximately 22 degree. Let's write it in radian. 22 divided by 180 is 11. So the values are 11 pi over 90, pi over 2, and 3 pi over 2. These are the 3 angles that will be the solution of number 49. Is it clear?
Yes.
Can you just repeat the first part that you did? 4 times 2 sine cosine.
Sine 2
part, yes.
theta, sine 2 theta, we know from the identities that it is 2 sine times cosine. So I replace sine 2 of theta by 2 sine times cosine. When you multiply it by 4, sorry, you will get 8 sine times cosine minus this part, which is a 3 cosine.
Okay, teacher.
Then we take cosine as a common factor, then you will continue.
Okay, teacher, thank you.
Type number 52.
Teacher, I didn't understand the last part.
This one here.
Yeah.
That's okay. Now, you know now from the equations, if you have x minus 2 times x minus 3 equals 0, what are the values of x here?
2 and 3.
2 and 3. Bravo. You say it first. X minus 2 is 0 and x minus 3 is 0. Here now we have the same. Here we have cosine times 8 sine minus 8 sine theta minus 3 is 0. So that's mean cosine of theta. It could be 0 or 8 sine theta minus 3, 0. Now cosine theta is 0. Which angles they are at? Pi over 2 and 3 pi over 2. And the second one here, 8 sine of theta minus 3 is 0. So that's mean 8 sine of theta equals 3. So sine of theta will be 3 over 8. Now what did I want? I want the theta. How did you find theta here? By what, Ragad? Sine inverse. Is it right? Ragad?
Teacher, she said her mic is not opening.
Okay. Now, Ragad, is it clear? Okay. Then, so sine inverse of 3 over 8 will be theta. Now, from the calculator, you will find that the theta here is 22 degrees. But since I write the answer, or I wrote the answer in pi, in radian, as pi over 2 and 3 pi over 2 for this part here, I need to convert 22 degree in radian. How did you convert it? You know it from chapter 13. We know that in order to convert it, you can solve it by that way, or you can divide 22 over 180 on the calculator. When you divide it, you'll find that it is 11 over 90 times pi, so it will be 11 pi over 90.
Okay, teacher.
Is it clear, Ragad? Yes, okay, thank you. Now, one 52. Okay, I will give you number 51 and 52 as a homework. Right, now let's solve, let's simplify. Number 53. In number 53,
Teacher, the
yes,
question.
I will send you on
What is
WhatsApp
the
later.
homework?
I will send you on WhatsApp.
Okay.
Number 53 now. 2 cosine squared of theta minus cosine 2 theta. We need now to simplify it. First of all, let's simplify cosine 2 theta. We can write it as cosine squared minus sine squared. Or you can write it as 2 cosine squared minus 1. And then replace 2 cosine squared as it is. So it will be 2 cosine squared of theta minus 2 cosine squared of theta plus 1. We cancel them. So you need to simplify it, you will get 1.
Teacher, is it plus or minus?
Plus, because here you have, let's do cosine of theta minus 1. Is it right? Or the
Oh
plus
yeah,
1?
with the minus. Yeah.
Yeah, minus. So minus times minus get plus.
Teacher, to cosine theta minus 1, is it from the Pythagorean identities?
No, it's from the double angle identities.
Oh, okay.
Number 55. Number 55 here. You have cosine 2 theta over sine theta plus cosine of theta. We want now to simplify it. Now, which identity we have to use?
Cosine squared theta minus sine squared
Bravo.
of theta.
Cosine squared of theta minus sine squared of theta over sine squared plus cosine squared of theta. Now remember here, we all of us know that if we have a squared minus b squared, we can factorize it as a minus b times a plus b. And if we have a squared minus b squared over a minus b, how we simplify it? We rewrite a squared minus b squared as a minus b times a plus b. We factorize it over a minus b. Then we will cancel a minus b with a minus b in order to get a plus b. So after we simplify it, we get a plus b. Now here we can make the same steps. Cosine squared minus sine squared, we can factorize it as cosine of theta minus sine of theta times cosine of theta plus sine of theta, like a squared minus b squared. I can factorize it as a minus b times a plus b over sine of theta plus cosine of theta. Then we cancel them. So we will get as a cosine of theta minus sine of theta. Is it clear?
Teacher, we can't simplify it more, right? It's just like that.
No, cosine minus sine.
Okay.
Do you have any question?
No, teacher, thank you.
Yeah. No. So after we talk about the double angle identities, now let's talk about the half angle identities. That sine the angle over 2 will be positive or negative square root of 1 minus cosine A over 2. And cosine of A over 2 will be positive or negative square root of 1 plus cosine of A over 2, and tan of A over 2, or the half tan identity, will be square root of 1 minus cosine over 1 plus cosine, like if you divide sine. So the two importance here, that sine of any angle over 2 will be square root of 1 minus cosine this angle over 2. Now here you have positive and negative. This positive and negative, in order to ask yourself the angle of A over 2, where is it lies? Is it on the first quadrant, second quadrant? Yes, so it will be positive. If it is in the third or fourth, the sign will be negative. And cosine of A over 2 will be positive or negative according to where that and to which quadrant that's I'm talking about. Square root of, it's the same, but it will be 1 plus cosine of A over 2. Now, how do you memorize it? Since I'm talking about cosine, so the plus will be with the cosine. But if I'm talking about sine, the cosine will have a minus sign. Now, how we will find the tan? In order to find the tan, we know that tan of any angle over 2 will be its sine over its cosine. So it will be square root of 1 minus cosine A over 2 over square root of 1 minus 1 plus cosine of A over 2. Then all of us know that the square root, it's like the exponents. It can be distributed in the numerator and the denominator. So it can be written as square root of 1 minus cosine A over. So I will distribute it. I will distribute the square root on each numerator and denominator. Then they cancel each other. So I have it as square root. I can say, I will write it in common as square root of 1 minus cosine A over 1 plus cosine A. These are the half angle identities. As an example, I told you find tan of 120 as an example. You will tan of 120. You will say tan of 120 divided by 2. It's tan of 60. Or لا مش like this. Sorry, just a minute. Tan of 30. You will say tan of 30. It's 60 over 2. So you will say it's square root of 1 minus cosine of 60 over 2. So positive or negative according to which quadrants that I'm talking about. Let's have an example here. So remember that sine of A over 2 is square root of 1 minus cosine. Cosine of A over 2 is 1 plus cosine. And tan of A over 2 will be 1 minus cosine over 1 plus cosine. Let's have an example now. Here, sine of 15. So by now we can solve, or we can find sine of 15 by angle sum, angle difference, double angle, and half angle. The sine of 15, in order to solve it by the half angle identities, we say that it is sine of 30 over 2, because all of us know that if you divide 30 over 2, you get 15. So it's sine of 30 over 2. Now remember that sine of any angle over 2 is a square root, positive or negative, 1 minus cosine of theta over 2. So here, this angle here, I will write it here. I mean, like, it will be square root of 1 minus cosine of 30 over 2. So I replace theta here with 30. Then, positive or negative? 1 minus, now what is the cosine of 30? Square root of 3 over 2. Over 2. So, it's positive, negative. Now, here we have it as 1, so we can write it as 2 over 2 in order to have the same denominators. So, it's 2 minus square root of 3 over 2 over 2. Just a second here.
Teacher, you make it like 30 over 2 because of the 15, right?
Yeah, and I want to find 15 degree, so I will write it as 30 over 2.
Okay.
Then, so here it's supposed to be square root of 2 minus square root of 3 over square root of 2 over square root of 2. Let's simplify it now as 2 minus square root of 3 under the square root over square root of 2 divided by square root of 2. Or, since we can change the division into multiply and write the reciprocal of 1 over of square root of 2, which is 1 over square root of 2. Then we will multiply the numerators here we get square root of 2 minus square root of 3 over 2. This will be here the sine of 15. Is it clear?
Yeah, teacher, only take the positive value of the square root because it's sine 15 first quadrant.
Thank you for reminding me. Now, since we are going to, the angle here is 15, and they told me that at which angle we are, for our quadrant, the angle lies. Since we are in the first quadrant, so the sign must be positive. So the answer is positive 2 square root of 2 minus the square root of 3 over 2. Is it clear?
Yeah.
Shall I repeat it?
Teacher, but just can you repeat the last part when you multiply it by 1 over square root of 2? What did you do?
Here, this part, okay? Look at me here. Here now, we have square root of 2 minus square root of 3 over square root of 2. They are divided by square root of 2. I just rewrite it. Now, when you divide a fraction into fraction, what do you have to do? First, you keep the first fraction as it is. Then you change the division to multiply. Then you will write the reciprocal of the square root of 2, which is 1 over square root of 2. Then, when you multiply, you have to multiply the numerators first. So you will get square root of 2 minus square root of 3. And when you multiply the denominators, such as square root of 2 times square root of 2, you will get 2.
Okay, teacher, thank you.
Yeah. Let's solve now another example here. Cosine of 150. Now, cosine of 150. How do you solve it? First, remember that which angle? That's if I divide it by 2, I get 150.
300.
300. So first of all, you will write cosine of 150 as 300 over 2. This is the first part. Now then, remember that the cosine of 2 theta is positive or negative square root of 1. Since we are going, I'm talking about cosine, so I have cosine of theta over 2. So where's my theta? This is my theta. So I will write now, instead of theta here, I will write 300. So it's 1 plus cosine of 300 over 2. Now, cosine of 300, remember the unit circle. It is 270 plus 30 degree. So it's here 60 degree negative. So here we have the 300 degree. Now what do we need to find? We need to find its sine. Now, and cosine. So we need to use the cosine and sine of 60. Cosine of 60 is half, and its sine is square root of 3 over 2. And since I am in a quadrant 4 and the cosine is positive, so this is positive and this is negative. So from the unit circle here, we can say that the cosine of 60 is always 300, sorry, is half. So we use this value here in order to solve cosine of 150. So positive or negative? 1 plus cosine of 300, we say it's half over 2. Now, until now, is it clear how we find cosine of 300?
No, teacher, can you repeat this one, please?
Which one? The unit circle?
The cosine 300, yeah. Like just in general.
Here. Now, how do you find 300? Or how you draw it? You see that it's like this. So it is far away from the x-axis, 60 degrees. So in order to know its cosine and sine, you know that cosine of 60 is half, and sine of 60 is square root of 3 over 2. Now, in the quadrant 4, the cosine is positive. So I have it as positive, and the sine is negative. Now here, I need cosine of 300, so which is half. Then here, I will reevaluate it in the identities that I have here. So what did we have? Positive or negative? 1 plus half, it's 3 over 2. Over 2. So it is square root of 3 over 2 divided by square root of 2. Or it's square root of 3 over square root of 2 multiplied by 1 over square root of 2, which is square root of 3 over 2. So the cosine of 150 now is square root of 3 over 2. Now, but since 150 is in quadrant 2, and in quadrant 2, the cosine is negative, so it will be negative square root of 3 over 2.
Okay, teacher.
So here, because I have less than 1 minute, I'll repeat quickly.